This lesson is about forming compounds, and the learning target is to be able to give the chemical formula and name of ionic and covalent compounds. And this video is specifically going to work on finding the chemical formula for these compounds made by two different elements. So when we're talking about ionic compounds, they're forming because electrons are transferring from one atom to the other, and that forms things called ions. And then those ions, because of their opposite charges to each other, a positive charge and a negative charge, are attracted to each other. And that attraction is what actually forms our compounds between two atoms. And so if we look at sodium chloride, we know about sodium chloride. This is just regular table salt, but it's formed from these atoms, Na, sodium, and Cl. And remember that our sodium has one valence electron. There's its Lewis structure, and our chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. And so remember that our chlorine is one electron away from a full outer shell, and it has 7, and so it's going to try to gain one electron. Our sodium is also one electron away from a full outer shell, but it's trying to get rid of that electron so that it gets rid of that partially filled shell. And so this electron from sodium is going to transfer over to our chlorine. Right, so if we were going to show this, what happens now, our sodium, again, lost a negative charge, which is a positive charge, and our chlorine now has its full outer shell, but it has a negative charge. It forms a -1 ion because it gained that one electron. Well, now we have a positive charge and a negative charge on these atoms. That's their net charges. And so these two ions are attracted to each other. And that attraction is what forms the bond of our chemical bond, forming NaCl. So our sodium is going to lose one electron, our chlorine is going to gain one electron. And so in our compound, we have one sodium and one chlorine are forming a bond together here. Now, if we were going to go look at our calcium and chlorine, look at the charges of these. Calcium has 1, 2 electrons. Chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. So our chlorine is going to try to gain one electron, fill its outer shell right here. Okay. And our calcium is going to try to get rid of 2 electrons to go down to a full outer shell. Now our chlorine can't take 2 electrons here. It only has this open spot for 1. Once it takes that 1 electron, it's going to have a full outer shell of 8. And so it's going to be stable. It's not going to be trying to find any more electrons. And so what this is going to take is 2 chlorines, both with an outer shell of 7, to take those 2 extra electrons from calcium. So what we're going to end up having here is calcium ion, and you can, and once you get this down, you can just look at your periodic table to figure out what ions these are forming. But our calcium is going to lose 2 electrons, so it's going to have a 2+ charge, as you see up top here. 2, oops, that's supposed to say plus. 2+. We're going to have a chlorine with a minus charge and a chlorine with a minus charge. And because we have opposite charges to each other, our chlorines are going to be attracted to this positive calcium, and we're going to have 2 chlorines for every 1 calcium, and so we end up with this CaCl2, which means I have 1 calcium for every 2 chlorines. And so this is going to be our chemical formula for the compound formed from calcium and chlorine, calcium chloride, which we'll learn how to name it in a bit. And so when you're figuring out how to do these ionic compounds and figure out what the chemical formula is, we start with the ions, and then we do something called the crisscross method to figure out how the chemical formula works for that. And I'll show you that shortcut here on the next slide. So as you're trying to figure out what the chemical formulas are for these ionic compounds, there's a little bit of a shortcut that we can do, and it's called the crisscross method. So you start with the ions that you're using. I know that sodium, let's zoom in here, sodium is Na, and it forms a +1 charge. And you can use your periodic table to find this. And I've got nitrogen. I know nitrogen forms a 3- charge. Now what I do, before I was drawing out all the electrons, showing how they transferred. I don't have to do that anymore. I'm going to draw Na and N right next to each other. And I'm going to crisscross these charges. This is why it's called the crisscross method. So this is really a 1 plus, so I should have rolled that down there. And I'm going to move this 1, right? That is going to become the number of nitrogens that I need. So I'd write my 1 right here. Now the plus and the minus doesn't matter for this. It's only changing over my number from the top left to the bottom right. Remember now, this is my superscript that's going to show me how many nitrogens I have. And so when I do this for my sodium, I take the 3 minus from my nitrogen, and that comes over, and that becomes the number of sodiums that I need. I need 3 of those. And you can check your work here. My sodium is a 1 plus charge. My nitrogen is a 3 minus charge. So that means I need 3 sodiums in order to make up for that 3 minus charge of my nitrogen. Now I rewrite this thing, and my chemical formula for the compound formed by sodium and nitrogen is Na3N. Right here, this is my chemical formula. Again, no positives, no negatives, just crisscrossing those numbers over. Now we're going to do some faster here. Li is a positive charge, O is a 2 minus charge. So I rewrite. Right here, I crisscross my 1 over to become my number of oxygens. My 2 comes over here. And the chemical formula for lithium oxide is Li2O. This is my chemical formula here. Okay, so now we can do some more of these. My aluminum is a 3 plus charge. My sulfur is a 2 minus charge. ALS. My 3 is going to come down here and be the number of sulfurs. My S's, or my 2 is going to come over and be the number of Al. Al2S3 is the chemical formula for this compound. For calcium is a 2 plus. Oxygen is a 2 minus. CaO. My 2 is going to come over here. My 2 is going to come over here. And I'm left with Ca2O2. And stop. When you're working with ionic compounds, this is only showing the ratio of these elements, these ions, with each other in these compounds. So like if I had actual calcium oxide, this would be in a big structure. And so there's way more than just 2 and 2. They don't form those little molecules like covalent compounds do. And so anytime that you have something like this where you can simplify the number, you're just showing the ratio. So what I'm really trying to show here is I have 1 calcium for every 1 oxygen. This is the one time, well, I hope it's the one time where the crisscross method throws you off just a little bit. You're showing that for every 2 calcium, or for every 1 calcium, oops, I need 1 oxygen to take those extra electrons. So this one would come here, this would come here, and I would only have 1 calcium and 1 oxygen. So this would be my chemical formula for those. But that is the crisscross method. It works pretty well once you get the hang of it to write the chemical formulas for our ionic compounds.